Hi viewers, welcome to Sevivali Kalvi channel. Let us see the Norton's theorem concept in electronic devices and circuits. So in last video we have seen about Norton's theorem for DC circuits. Let us see the Norton's theorem for AC circuits. So here we consider one circuit so which consists of both resistive component and reactive component. So that means resistance, inductance or capacitance which is called as a reactive part. So here 5 ohm resistor is there and 4 ohm and one inductance value J4 ohm also there. So here the two terminals A and B is connected in between of this reactive parts. So we can consider this is impedance value. So according to that, this concept we are going to find the load current. So before going to see in depth of this problem solving concept, we have to consider whether this circuit is AC circuit or DC circuit. So whenever you have a voltage source with the function of sine function for voltage with some angle value, so from this we can surely consider this is the AC circuit. At the same time, both resistive component and reactive components also included in your circuit. So from this two concept and based on this voltage source and also our impedance value, we understand that this given problem is the AC circuit. So now we move to find the load current value with the help of Norton's theorem concept. So our question is find the Norton's equivalent circuit for the given figure and also find the load current IL. So the what is the load current between these two terminal? It is to be find with the help of this given circuit. So in step 1 you have to find the Norton current. So for this you have to calculate this Norton current IN. So the notation or representation for Norton current is denoted by IN, otherwise which is called as the short circuit current ISC. So the short circuit terminals of AB. So from this consideration, the circuit is redraw again from the given circuit. So 5 ohm, 4 ohm and J4 ohm which consists of voltage source, that is AC source with a value of 4 volt with angle 0 degree. So now the terminal between A and B is short circuited. So from this we can find the Norton current value. So the Norton current IN which is equal to V divided by R. In this question we have the voltage value 4 volt with angle of 0 degree and resistor value only 5 ohm, because here the A and B terminals are short circuited, so then there is no current flow through this 4 ohm and J4 because of this short circuit concept. So we have to consider only this voltage value and this particular resistance value. So 4 angle of 0 degree divided by 5, we can find the current value which is called as Norton current or short circuit current, IN or ISC. So from this, numerical value is denoted in the form of polar form. That means your voltage value which consists of angle, so which is divided by the denominator value resistance, only pure resistive value with without any angles or some other thing. So here the 4 divided by 5 is divide, and finally we get 0.8 with angle of 0 degree. So the IN is the Norton current which is 0.8 with angle of 0 degree amps. So in steps 2 we have to find the ZTH, otherwise simply we can know or find out the Norton impedance. So normally we know the Zn which is equal to Zth because of dual theorem of concept of Thevenin's and Norton's theorem. Here the Zth is equal to Zn. So Zth can be determined with the help of this given circuit. So in this case we have only voltage source. So you have to find the Zth in between of these two terminal A and B. and because of this available voltage source, you just remove this voltage source and short circuit it. Finally you have the circuit like this. So with the help of the circuit we can able to find the ZTH or Zn, that is Norton impedance value. So this 5 ohm resistance is parallel with the summation of 4 plus J4, because these two are connected in series, so resistance and inductance values are arranged in a series manner, so 4 plus J4, and this series combination of resistance and inductance is parallel with this 5 ohm. So 5 into uh, 4 plus J4 divided by 5 plus 4 plus J4. That means the parallel value can be determined with the help of R1 into R2 divided by R1 plus R2. The same formula can be applied here, and we can able to find ZTH value. So here we have to determine the ZTH value with the help of proper concept, because here the 4 plus J4 is the rectangle form. So you have to convert this rectangular form into polar form with the help of calculator. So in scientific calculator you have to convert this rectangle form into polar. So you will get answer 5 into 6, 5.65 into 45 degree. So this value is for 4 plus J4. So this pure resistance value, uh, which does not consist of any reactive part. So simply we get the polar form value 5 angle of 0 degree. So now again you have to calculate the polar form answer for denominator. So here 5 plus 4 is the resistive part and J4 is the reactive part. So 5 plus 4 9 plus J4. So this is your rectangle form. Now you have to convert this rectangle form into polar form. So using calculator, 9.84 with an angle of 23.96 degree. So this is answer for denominator value. So here we have to consider both all three parameter. That means the all three values are in polar form or not. You have to consider it. So all three values are now available in polar form. So in numerator value, we can multiply this value 5 into 5.65. We will get 28.25, and the angle 0 degree and 45 degree will be added. So finally we will get 45 degree. Similarly, denominator value 9.84 divided by 23.96 degree can be taken as it is. So now you have to divide this two value. So whenever you consider the both numerical, numerator and denominator value has same form, that is polar form, the value should be divided and the angle value should be subtracted. So 28.25 divided by 9.84 can be applied, and finally we will get the divided value 2.87, and the angle value 45 should be subtract with the 23.96, so 21.04 degrees your answer. So this ZTH or Zn value is calculated or determined with the help of this concept. So 2.87 with angle of 21.04 degree ohm is the Norton impedance value for this given example. So in step 3, we have to find the Norton's equivalent circuit. So we can draw the Norton's equivalent circuit, which consists of Norton current, which is parallel with this Norton impedance, and load resistance or reactance, which is given already in your question. So Norton current value we already determined 0.8 angle of 0 degree amps. So that can be drawn here, and Zn value is 2.87 with angle of 21.04 degree ohm. So now the impedance value already available in the question itself. So 4 J4 omega. So this is the Norton's equivalent circuit. So from this we can find the load current. So what is the load current in between of this terminal A and B? So for this we have the formula Norton current into Norton resistance divided by Norton resistance plus load resistance. So the same concept, instead of RN. If you consider a DC circuit, you have to put RN, RL. So in this case, we have to consider ZN and ZL. That means instead of this RN Norton resistance, Norton impedance should be taken, and load resistance, the 4 plus J4 is the load impedance value. So that value can be taken here. So Norton current value is 0.8 angle of 0 degree into Norton impedance value 2.87 into angle of 21.04 degree, divide by the same value is taken here, plus RL is 4 plus J4. Now both numerator and denominator values are available in same format or not should be checked. So the numerator value, both values are in polar form, but in denominator one value is polar, another value is rectangular form. So we have to convert this polar form value into rectangle form. After that we have to combine both values. We get the answer in the form of rectangle form. After that we have to convert it into polar form. So after getting polar form of numerator value, we can multiply numerator values 0.8 into 2.87 and add this numerator angle value 0 plus 21.04, and after that in denominator value also consider in the form of polar form. Finally we have to divide both numerator and denominator value in the form of polar. Finally we will get IL load current value is equal to 0.274 angle of minus 15.98 degree amps. So with the help of this Norton's theorem, we have to find the load current between any two terminals using AC circuit is determined in this example. I think everyone understands this concept clearly. So hope I can clearly explain this concept. So kindly see this examples, and if you have any doubt, you can ask me at any time. Kindly go through my videos and subscribe my channel. If you have any comments, kindly give the comments and put like. Thank you all.